Hello students, welcome to class 11 physics. In this video we are going to study about the center of mass. So first of all, let us see what is center of mass. The center of mass of the body is the point where the entire mass of the body is supposed to be concentrated. It is known as center of mass. That means generally students are confused with the word mass and they think that it is mass, but center of mass, it is not the mass, but it is the point where the total body's mass is concentrated. Now let us obtain an expression for the position vector of center of mass of a system of n particles in one dimension. That means here we are going to consider the system of particles in one dimension, and for that system of particles we are going to find the center of mass. As discussed earlier, center of mass is the point where the total body mass is concentrated to. Now according to as shown in figure, let the distances of two particles be x1 and x2 respectively from origin O. Let m1 and m2 be respectively the masses of the two particles on x-axis. So as the question is given, we are finding the center of mass of the system which is in one dimension. So here we are considering that the object or the system is along the x-axis. And here let us consider that this system is made up of two particles. First of all, let us consider that. So particle 1 has mass m1, particle 2 has mass m2. Here we also need to denote the position of these particles, and we know that to denote the position of the particles we will be needing the reference point. So here the origin of the xy coordinate, that is taken as the reference point. So the particle 1 has position x1, that is from O, and the particle 2 has distance x2 from O. So we got the positions of particle 1 and particle 2. So with the help of this information, that is the mass of the particles and its position with respect to reference point, we can find the center of mass. So the center of mass of the system is that point C which is at a distance x from O. Then, so here we have seen in the figure, point C is the center of mass and the position of that is distance x from O. This distance x from O. So the formula for the center of mass is given as x equals to m1x1 plus m2x2 upon m1 plus m2. That means to find the center of mass of the body, we should know the masses of all the particles as well as the positions of all the particles. And to get that center of mass, what we need is to sum up the product of the masses and positions of the particles, and we need to divide that by the total mass. So here we are having only two particles, so we need to sum up that. Sum up what? The product of the mass and the position of particles. Here m2 x2 is mass and position of particle 2, and we need to divide by the total mass. Total mass, that means here we are having mass of particle 1 and mass of particle 2. So here x is the mass weighted mean of x1 and x2, that is the average mass. If the two particles have the same mass, then the above formula can be rewritten as, in that we can take m1 equals to m2 equals to n. Then x equals to mx1 plus mx2 upon m plus m. So taking here m common in the denominator, we get m into x1 plus x2 upon 2m. So m gets cancelled and we will be having x1 plus x2 by 2. Here for two particles of equal mass, the center of mass lies exactly midway between them. That means when all the particles will be of the same mass, then the center of mass will be at the center. So in this case also, we are having two particles and masses of these two particles are same. So the center of mass lies between these two particles, that is half in the midway or halfway of the two particles. Similarly, n particles of masses m1, m2, m3 up to mn, their respectively distances x1, x2, x3 up to xn from origin on x-axis. Their center of mass of system of particle is given by the formula. Here we are having n particles, so we need to get the product of the mass and the position of each particle and summing up that and dividing that by the total mass. So in the numerator what we will be having, m1 x1 plus m2 x2 plus m3 x3 up to mn xn upon m1 plus m2 plus m3 up to mn. So in general we can write, here we are having summation of, that means we need to use the summation symbol. We are having summation of what? The product of the mass and the position. So we can in general write mx. You can see over here for each particle we are denoting 1, 2, 3 and so on. So in general we can take the variable I. So mi xi. Here we are choosing the same variable because in every term you can see if m is having 1, x will be having 1. That means we are taking mass and position for one particle, then mass and position for second particle. So we are choosing the same variable. Here we are taking from 1 to n, that is I equals to 1 to n, upon we are having m1 plus m2 up to mn, that is total mass, that is summation of m, again taking variable I equals to 1 to n. So this is the general formula you can write. So we have summation mi equals to m1 plus m2 plus m3 up to mn, and that can also be written as capital M as the total mass of the system, that is summation mi xi upon capital M, where I equals to 1, 2, 3 up to n. So students, you may note down this theory. Now let us see the expression for the position vectors of center of mass of a system and particles in two dimension. So suppose that there are three particles not lying in a straight line, so they are taken in a plane. So as you can see in the figure, we are having the system of particles in two dimension. Here we are taking xy coordinates, and the system consists of three particles over here. Let us consider this first particle. So its position is x1, y1. If we take the projection along x-axis, we get x1 coordinate. When we take the projection along the y-axis, we get y1 coordinate. In the same way for the particle 2, when we take the projection on the x-axis, we get x2 coordinate, and when we take the projection on y-axis, we get y2 coordinate. In the same way, the third particle, when we take projection on x-axis, we get x3 coordinate, and when we take the projection on the y-axis, we get y3 coordinate. So for particle 1, the position is x1, y1. For particle 2, the position is x2, y2. And for particle 3, the position is x3, y3. So here, for this system of three particles, we are going to find the center of mass. So suppose the coordinates of the three particles of masses m1, m2 and m3. That means the masses of these three particles are denoted by m1, m2 and m3, and x1, y1, x2, y2 and x3, y3 in two dimensions respectively. If the center of mass of the system is xy, then x coordinate of the center of mass be. So we have seen already that the center of mass for a particle that lies in one dimension, that was m1 x1 plus m2 x2 and so on upon the total mass. But here the system of particle lies in two dimension. That means here we have seen that each particle has the position with respect to x-axis as well as the y-axis. So here the center of mass will also be having the x coordinate and the y coordinate. So let us see the center of mass of the system individually by x coordinate and the y coordinate. So for x coordinate, the formula is m1x1, because here we are having 3 particles and we already know to find the center of mass, in the numerator we should have the summation of the product of the mass of the particle as well as its position, and here we are taking 3 particles. So first term will be m1x1, that is product of the mass of the first particle and its position with respect to the x-axis, and plus m2x2, which is nothing but the product of the mass of the second particle as well as the position of the second particle, plus m3x3, that is the position of the third particle, that is x3, that is multiplied with the mass of the third particle, divided by the total mass. Here the total mass is the mass of the all 3 particles, that is m1 plus m2 plus m3. In the same way, we can find out the y coordinate of the center of mass. So instead of the position with respect to x, we will be taking the position of the particles with respect to the y coordinate. So y coordinate is equals to m1y1 plus m2y2 plus m3y3 upon m1 plus m2 plus m3. Therefore, if we want to write that in the combined form, then we can write it as xy, and we can denote it like this: m1x1 plus m2x2 plus m3x3 upon the total mass, comma m1y1 plus m2y2 plus m3y3 upon the total mass. The same thing can be written as in terms of r, because here we know that position of any particle that is represented by vector r, and here we are having 2 coordinates that can be written as xi cap plus yj gap. So instead of this xy, we can also write it as r vector. Now suppose if we consider that all the 3 particles are having same mass, then we can write m1 equals to m2 equals to m3 equals to m. So for x coordinate of the center of mass, it becomes mx1 plus mx2 plus mx3 upon m plus m plus m. So taking m common in the numerator, we will be having x1 plus x2 plus x3 upon 3m. So mm gets cancelled and we will be having x1 plus x2 plus x3 by 3. In the same way, taking the y coordinate for the center of mass, it will be my1 plus my2 plus my3 upon 3m. mm gets cancelled and it will be y1 plus y2 plus y3 by 3. Hence, the center of mass of system formed by 3 particles of same mass will be at the middle of the triangle formed by these 3 particles. So, when any system of n particles consists of the same masses, if all the particles will be having the same mass, then the center of mass will be lying at the center of the system, that is at the center of the body. Thus, the center of mass of 3 particles which are not lying on a line is written as coordinate of center of mass, that is xy. In the same way, we can write like this also: m1 into position of the particle, that can be written as x1 y1. So m1 into x1 y1 plus m2 into x2 y2 plus m3 into x3 y3 upon total mass, that is m1 plus m2 plus m3. In general, we can write like this because we are taking the summations. So writing sigma equals sigma into, we are taking the product of the mass. So in general, we can write m, and the position. So in general, we can write x, y. But here we can see for each particle we are denoting by the number 1, 2 up to n. So in general, we can write the variable I. So mi into xi, yi. And we can see over here we take the particles from 1 to n. So here I equals to 1 to n upon the total mass. So this is how you can write the general equation. Instead of capital M, that is the total mass of the a system of n particles, we can also write it as summation mi. So students, you may note down this theory. Now let us see the general expression of center of mass for distributed n particles of system in 3 dimension. So suppose the system of n particle is in 3 dimension. Let it has n particles and its masses are m1, m2 up to mn. And the position of each particle is x1, y1, z1, x2, y2, z2 up to xn, yn, zn respectively. Thus, the position of the center of mass will be in terms of x, y and z. That is, we can write in the numerator summation of the product of the mass and the position of the particles. So for the first particle, it is m1 into position x1, y1, z1 plus m2, x2, y2, z2 up to mn, xn, yn, zn. And in the denominator, it is the total mass. So in general, it can be written as summation of mi, xi, yi, zi, where I is from 1 to n upon summation of mi. You can write that in terms of x, y and z separately. The x coordinate of the center of mass is m1 x1 plus m2 x2 up to mn xn upon m1 plus m2 up to mn. In the same way, y coordinate is m1 y1 plus m2 y2 up to mn yn upon m1 plus m2 up to mn. In the same way, the z coordinate of the center of mass, that is z equals to m1 z1 plus m2 z2 up to mn zn upon m1 plus m2 plus up to mn. In the same way, instead of x, y and z, it can also be indicated as r vector, where r vector is equals to xi plus yj plus zk. Thus, the general formula can be written as r vector equals to summation of mi ri vector upon total mass, that is capital M. If the origin of the frame of reference taken as the center of mass of the system, then for the system of particles, summation of mi ri vector equals to 0. So students, you may note down this theory.